Thank you everyone for joining us today for Archipel Western Australia IES webinar. We can go through some introduction and then others can join while we start. So it's a great pleasure for me to introduce our speaker today, Rob Susanto. Rob is going to talk about the interesting topic on the control and monitoring system. Today's is our second webinar for this year, 2022. Over last 2 years, IES had at least 9 to 10 technical webinars and for each year, and we're trying to continue this for this year as well. You can follow the Eventbrite link and you will be notified for any events in future as well. Rob is an automation and control principal engineer and a manager at APD Engineering. Rob is also a chartered professional engineer of Institute of Engineers Australia. He has a Master of Electrical Engineering and Renewable Energy with over 25 years of experience in SCADA and process control system design, team management, development, commissioning, and maintenance. He has also experience in the mining, gas, power, water, and wastewater industries with specific interest in renewable technologies. Before I hand it to Rob, please make sure during the presentation, put your mic on mute. If you can hold your questions to the end of the presentation, we will have around 15 to 20 minutes for question and answers and any discussion around the topic. Please also that this session is recorded and the recorded file will be available through the IES YouTube channel. Thank you, Rob, and thank you, everyone. Rob, it's all yours. We can start. Thank you.
Okay, thanks, Mayed. Appreciate that. Okay, let me share my screen. Mayed, can you see that?
Yes.
Okay, well, I'll get started. Thanks for having me. Hi, everybody. Well, I'll get right into it then. So when you develop a solar farm and you want to connect to the grid and make money ASAP, so that pays for itself as quickly as possible, you certainly don't want something that costs like 1 or 2% of the whole asset to cause any delays. Well, that's exactly what can happen when you overlook this one thing, which is communications. And communications for control and monitoring of this asset in particular. So today I'm going to cover what this control and monitoring is, why it's essential, and how it can cause delay, the dreaded word, delay. So I'm covering 3 things here. So first I'll define what it is, control and monitoring, what we do, what we as control engineers mean by control and monitoring. This is our perspective, and then we'll go through the types of things that we control and monitor in a solar plant, and the communications issues that arise in implementation, and we'll discuss some real-life examples of these implementation issues that we've experienced. So I'll start with what is control and monitoring. Simple one. So control and monitoring is what a plant operator does. By plant, I mean production plant. So it could be a plant that produces power. In this case, that's what we're talking about. But it could be producing iron ore, potable water. It's a production plant. And a control monitoring system enables that operator to control and monitor the various components of that plant. So I'll try to illustrate this by using a parallel scenario. Although there's probably a million other simpler examples, this is my parallel scenario, and it is an Uber Eats driver. So I trust you're now very familiar with this service, having survived a pandemic. But for this scenario, imagine you are the Uber Eats driver. You're the owner and operator of this asset, which is your scooter. And this is basically the plant that helps you generate your income. You operate the scooter using controls like steering, accelerator, brakes, and monitoring. So speedometer, fuel gauge, that stuff. And you receive food orders from Uber Eats over the mobile. You pay for each order that you complete. So I'm drawing a parallel of that to a solar plant. So you are the owner and operator of this asset. this solar plant, which helps you generate your income. You operate the solar plant using control. You open, close the grid connection, send it generation set points, whatnot, and you monitor it. You know, generation measurements, like active reactive power. You monitor your assets, you know, inverters and trackers, all that data. And you also receive generation commands from the market, and you paid for the power that the plant generates. So that's pretty simple. Hope that paints a picture of what we generally mean by control and monitoring with respect of a production plant. So now we'll just go a bit deeper into the solar plant. So for greater detail regarding types of equipment that you control and monitor in a solar plant. So there's lots of components that can be controlled and monitored in a solar plant. These days, these components are smart devices, meaning that they're little computers, their own operating systems. They perform a particular function pretty well on their own. So think of your phone, your TV, car stereo. These days, everything's a smart device and can communicate with each other with some communications method that's been defined, like think of Bluetooth. You know, that's a communications protocol. So that's sort of what we're going to talk about today. In our industrial communications world, there's a million different types of communications methods or protocols. Most are well defined, though not always well implemented or similarly implemented between two devices. So, and we'll cover that a little bit later, but when in this slide, the reference to local devices is a reference to devices that are local to the plant itself, as in resident at the solar farm, switch room, or elsewhere on the plant. And you find protection relays, power quality meters, solar inverters, solar tracker controllers, weather stations, lots of other stuff. But who is looking at this stuff? So who's doing this control and monitoring? So who's interested? So, well, they're usually entities that are external or remote to the plant. And these entities actually include the asset owner, such as, well, think of projects here for Solar, Canadian Solar. They're interested in their asset, how their asset is performing, for maintenance purposes. You know, it does depend on their operational strategy. There could be on-site personnel, but usually it's remote, so they look at it from somewhere else than site. Also, the transmission or distribution network operator is interested in the data that you get out of the solar plant. So think of network operators, Western Power, Transgrid, South Australia Power Networks, etc. And the market operator, AMO, Moyed, you, they're interested in how much power this solar farm is generating, power quality, and the ability to start, stop, or curtail generation. So that's who's interested. And I think we've talked about the local devices, but to bring the local devices and all these external entities together is a device called a site gateway. So the site gateway is a device that communicates to all these local devices and external entities, so they can exchange data and exchange information as required. So, and all that information can be represented visually to an operator, to different operators remotely. And essentially they all communicate to each other, you know, to all these various devices. Well, at least the site gateway communicates to all these various devices via different communications protocols. So that's why the site gateway is also often referred to as a protocol gateway. So now we'll zero in a bit more on protocols and comms. So now establishing communications between devices is not always easy. So, and it depends on, I think I mentioned earlier, you know, how the protocol itself is implemented by the two partner devices, and the implementation of that protocol itself. It's because it's like an accent in speech, like an Australian accent or an English accent, but it's a lot less forgiving if you don't quite speak with the right way. We will not communicate, won't understand. And that relies a lot on communication protocol parameters, which includes like actual device addresses, communications ports, channels, packet structures, etc. And it's a very defined form of communication. So to get good comms, you must talk the same language, protocol, as we said before. You must also agree on the content that you're going to share, data mapping, etc. So I think hopefully we established now getting comms going can be difficult. All those of you who've tried it know what I'm talking about. But how do these communication issues cause network connection delays? Well, because the plant can only connect to the power network when the network operator's control and monitoring requirements are met. And these requirements that I'm talking about are actually derived from the NER. There you go, version 179 is the latest one. And for generators, they're addressed under clauses 4.11.1, remote control and monitoring devices, and S526 of the NER. Towards this, compliance testing is performed by the power network rep prior to grid connection. And this is part of the compliance test, is to make sure that you have the right communications working. So passing these tests are dependent on those communications links we mentioned about to be fully functioning. So network connection delays occur when the controls, this is an example project that I've got on the left there. So the example of the signals that were required by the distribution network operator at the time to connect to their network. So signals from the network provider include like heartbeat, permission to connect signals, generation, dispatch limit, set points, etc. And then you have signals to the network provider, which include generation currents and voltages, and active and reactive power measurements, etc. So what that means is that the plant would only be able to communicate, to connect to the grid, if the site gateway can actually talk to all those devices, specifically the ones that are included in this list. So you must talk to those links in red. So communications to the network operator site ITU is a must. Power quality meters, protection relays, inverters, etc. So they must be established and working, fully functioning, so that you can achieve grid connection. So I hope that's clear. So I'm going to go through a few examples of the issues that occur when we're trying to implement this monitoring and control. So a lot of the times it's usually because we haven't been able to get access to devices for communications testing. So on the left is a picture of a config testing lab here in Perth. So ideally should have the most important component, that's the site gateway, as we mentioned before, available in the lab for offsite configuration and testing. But to ensure that eventually it'll do its job right on site, it's ideal to have the partner devices that it's going to be talking to available for testing as well. So on this particular project, some of these devices were available for offsite testing, but even being that prepared, we encountered a few issues. So as prepared as we hope to be, we're hamstrung by what essentially became project management issues, as there were lack of understanding by the project development team of what was actually required for system integration. So, and on top of that, it was never a contractual requirement for the vendors to make equipment available for the functional or integration testing. So it was difficult to get some of these devices to the lab. So best illustrate how unpredictable these communications issues can be is this device. This is the solar tracker controller on this particular project that was used. And I'll quickly go through what the system does. It's essentially where the smarts are So the solar tracker controller ensures the PV panels face towards the sun over the day. The PV panel's orientation for each string is controlled by tracker actuator motors, which follows a calculated path throughout the day. And in this plant, there were two main controllers that controlled around 50 motor control boxes each. So we thought we got on the front foot by requesting this controller early for configuration and testing. And we received this communications box in the development phase, but it was not functional. So later we discovered that there was no firmware loaded in it. And the product documentation and support was poor. So testing could only be commenced on site when the solar tracker commissioner, completed his job. So we had to wait for that to happen. And the equipment representative was technical, but more on the overall system and mostly mechanical and LV electrical. So by no means a control specialist. So as a result, it was difficult to get stuff done. So it was discovered on site by our own investigation that the controller takes up all of the Modbus addresses, hence can only be the only device on an RS485 network. So we had designed it so that it wasn't the only device. So I'll show you just the slide after this, but we had to actually do all this stuff on site, which causes further delays. So data mapping was performed on site through a bit of R&D, trial and error. So that's probably the worst thing you probably want to do. So this is with design that we had. So previous design had that daisy chain because we assumed that you can have more devices on this network, but eventually, because the tracker controller took up all 247 possible slave addresses, it had to be on its own network. So we had to source and ship another Modbus to Ethernet converter to site, which, yes, you can imagine, introduced yet another delay. So how do you avoid this? Well, here are some suggestions to avoid the types of issues I mentioned earlier. So in the design phase, ensure that communication standards are established and integration requirements are made clear. In the procurement phase, ensure that the specified communications requirements are well understood by the vendors, so work with the vendors, and that offsite system integration testing is part of their deliverable. If you can get that through, be nice. In the development phase, ensure devices are made available and for testing and perform integration testing with vendors wherever you can. Early contact with the vendor commissioning personnel. Also reduce the unknowns. Hopefully they've got specific skilled personnel who can actually help you on site. And of course, in the commissioning phase, ensure that the vendor commissioning personnel that understand the communications requirements are also available on site to ensure integration, and you're not trying to do this over the phone to someone that is difficult to understand. So last slide here. So control monitoring system is dependent on reliable communications between all the components. So without it, you cannot efficiently run your plant or sometimes connect to the grid. Communications issues may remain hidden until they become critical path. That's always the way. So one way around it is ensure vendors understand your system integration requirements as early as possible. So if you're looking to develop a renewable plant, I hope this presentation helps in understanding how control and comms can delay a grid connection. That's the end of my presentation. Thank you.
Thank you, Rob, for your nice presentation. So we're waiting for any question, and if anyone has a question, please ask Rob.
Hi Rob, this is Harish here.
Hey Harish, how are you?
Good, how are you? So recently we commissioned the solar farm. We know how much important that communication, testing is required. Yep. So now, what do you suggest? Do you suggest this has to be done in a FAT, like before coming to the site, through all the comms at FAT? so that on the bench top, yes, everything is talks to each other, and then
Yes.
All these things can be identified in FAT.
Well, ideally, were you not able? Well, that's what I was actually talking about, Harish. Sometimes you're not able to get those devices, and that
Exactly.
you
So
end up having to do it on
invariably,
site.
that's what invariably. So we came to site and then we found that FAT everything worked, but at the site we had totally different issues on the comms. Comms was okay, but then we had this on and off comms issues, dropping off, and we had it took a lot of time to understand what is happening.
Was it protocol related, or was it actually your network?
It's the network. I mean, the solar farm network. We had a lot of. I mean, as you know, in the solar farm, like there's a lot of devices, right?
Yes.
There's a lot of traffic, and then everything is so we of course it's designed for. I mean, the solar farm is not new. It's been installed at many places, but then every site is unique. Different
of
problems.
Course.
Yeah.
Every installation is unique. Exactly.
Exactly. So we had the issue of this comms dropping off every now and then tripping the power converter stores. So eventually we found, because of the packets dropping off in the network. Why is it? It's because of ARP. It's all about technical aspect, like ARP flooding and things like that. And then finally we found out, okay, what was the problem, and we fixed it. But then how will you? That was the main delay in our project.
Yeah, I see.
So now I'm trying to understand how we can get away, how we can prove it in FAT, so that we can, when we come to the site, everything works together.
Oh,
I don't know.
Good question. I mean, in projects that we've been involved with, sounds to me like you have a lot of network devices that should have been almost like it's like a comms FAT in terms of if you're establishing rings and establishing network segments and LANs and all sorts of stuff. That kind of stuff you should have done in a lab and ticked off before you take it to site. But did you have access to the equipment?
We didn't have the access to the equipment. Eventually, we had to do some trial and error, as you mentioned, separating some of the devices, high demand devices like PQM meters and stuff like that on a separate stuff. Because any packet loss from that PQM, like the connector grid and disconnector grid, it just happens because of the comms loss. So it used to trip straight away. So we were identifying what was the issue, and then eventually we had to separate that network. Really? And then everything was okay after that.
But it's not as designed, is it? I guess that's
so it's a unique design for this site. Didn't happen in a different site. So.
I'm sure that happens in a lot of sites, to be honest.
Yeah. That was my lesson learned in this project, and this was my first solar farm project anyway.
Well, I recommend if you are involved in tender evaluations, to stick it in the technical clarifications and make it part of the contract.
Correct. What I was trying to put forward is there is no single solution for this one. Now I have done this commissioning of the solar farm. Now if I go to second job doing similar solar farm, I might face a totally different problem. I don't know.
Oh, we're in controls and comms, mate. That's what happens. Exactly. But yeah, that's it.
Yep.
Thanks, Harish.
That's it.
Good to hear from you.
I got the link from Nick.
Okay.
Thank you. So, Rob, we have a question on chat box from Irfan asking, do you mind elaborating more on how does the solar tracker use all the Modbus channel when the expectation was otherwise?
G'day, Irfan. How are you? Yeah, well, good question. The expectation was otherwise because we had very limited documentation, and I think I mentioned in that thing where we actually did get the box sent to us early, but it had no firmware. So we thought we were on the front foot, but we we didn't quite get there because with the support, I guess the product support was a bit lacking generally. So what ended up happening is that what they developed, and this was like almost a, it's not an off-the-shelf product. It's something that, it was just part of the sort of custom-ish for part of the delivery of this solar tracker product. What ended up being is a Modbus gateway. So yes, it'll take up all the addresses, but yeah, that wasn't what we had designed. I thought that's not what we thought it was going to be. Hence, we designed our balancer plant around something that was just a single address slave. Don't know if that actually answers your question, but that yeah, I guess the answer to your question is that we didn't have enough information, and we designed our balancer plant based on what we had.
Thank you. We have also Jason asking about NER, asking what is NER? I'm only familiar with ESO. Is it similar to that?
Do you want to answer that one, Mayed? I think you'd know.
Yeah, I do too. So.
National electricity rules. So that's the Australian. I think you can explain this one better, Mayed, maybe.
Yeah, so it's different than is also national electricity rules that we have in Australia. So so we have WEM rules and we have NER rules over for Australia. So it's different, completely different.
Yeah. So it nope.
Yes, go ahead, Rob.
Oh, sorry. No, I was just reading some of the meeting chat. Yeah. So the NER rules does govern, or at least specify rules around the electricity networks around Australia, Jason. So whether you're a generator or however if you're a customer on the network, it defines all the rules to connect to the grid and so on and so forth. ISO is more engineering standards, so to speak, as I understand it. So.
Thank you, Rob. Any more questions?
Hi, Rob. It's Remember here.
Hey, how are you, mate? How's things?
I'm good. Very good. I have a question. I don't know if it's directly related to you guys control and automation, but I think it should. There is this system of forecasting that they are sort of trying to bring to integrate in the control of solar PV. Normally very short-term forecasting. So my question is, I don't know if you had ever heard of nowcasting, where they're using sky cameras to try and sort of manage or schedule PV output, for example. So my question was, if this system not yet really being utilized, but if this system was to come into play, would that complicate the control mechanism, or is it a feasible system? If you've heard about it, do you think it's feasible to actually integrate this into, because that's like addition of a new signal into the control algorithms? So yeah.
Good question. Look, I have not actually dealt too much with the cloud forecasting software. I imagine that it would, yes, you're right, talk to the site gateway, and then the site gateway would vary because the site gateway interacts with the inverters, etc., and vary set points from that angle. But
yes.
So what's this new? I'll have to look into that one. Remember that? What is it called? Nowcasting, is it?
Nowcasting, yeah. That would be like a very short-term forecasting, maybe up to 15 or 60 minutes ahead from 1 minute.
Okay.
Yeah.
I'll have to look into that. Thanks, mate.
Sure. Thank you so much. Yeah. I just thought I would bring it up.
No, thanks. Yeah.
Yeah.
Actually, oh, hi. Hi, Fraser. How and why are different protocols chosen? If you're talking about just the electrical industry, generally there is the standards have been defined by different industries, I suppose. So, are you a automation substation automation engineer, or are you a process control engineer?
I'm just a student. I'm just like kind of interested, just in maybe like why protocols have different advantages or requirements.
Well, they're generally born of different industries. So in the electrical industry, a lot of the well, historically, the way they've actually developed over time is they contain timestamping as well. So you have things like IEC 6870-5104, 101, which DNP3, and then 61850. So all these protocols have timestamping associated to them because timing is important for all the signals. So essentially, where the event actually gets registered or made, it is stamped with a timestamp. So because the events are there are millisecond events that occur, so you want to timestamp them at the point that they occur, such as protection relays and all that. And so that there are specific industrial or practical reasons why you would select protocols. So in process control, however, where processes are slightly slower, because if you're dealing with water or anything fluid, then it can tolerate slower reaction, so to speak, or monitoring, and so you have other less time deterministic sort of protocols like Modbus and Ethernet.
Yeah, sweet. Yeah, that's a good answer.
Okay. How do you manage user interface testing during design stages? Users are typically network controllers who aren't really involved in design process. Hey Kai, that is a good question. Yeah, network controllers generally, get what they're given, and we train them to use the software. At times they do have a say. Obviously, maybe if operators if there's such a thing as operational readiness team for a plant owner or operator, and they might even come to an FAT or something like that, and then in that phase they can actually look at the screens, operate it, make comments, and then we'll modify the system as to the comments to an extent, in a limited way. But in my experience, no, it doesn't cause delays. They wouldn't. Those are not major issues. If you're talking about user interface, graphical user interfaces, and all that, it's not too critical usually, and usually it's easy to change as well. So yeah, they don't usually cause delays.
Thank you, Rob.
Whereas,
any more questions from participants? Thank you. I think that would be the end of today's session. Thank you again, Rob, for your nice and interesting presentation. Very useful. And thank everyone for your participation. Thank you.
All right. Thanks, guys.
Bye.
See you later.
Thanks, Rob.
Bye. See ya.